Okay.
Let us begin. Let's talk about some basements and some foundations.
Well, I mean, the whole reason that we decided that we wanted to do this video, it's not, I mean, we enjoy talking to each other a lot, but it's sort of for people to, it's really to demystify parts of the house. Because we both spend a lot of time in houses, our own houses, other people's houses, just because of the nature of the services that we each provide with our businesses. And we talk to people who, there are just some basic questions that people have about how their houses work. And so we thought that we should have a conversation, get it on video,
share it, and put it out there in the world.
Yeah, talk about things how we look at houses, how we understand them, and demystify them a little bit for people.
Absolutely. Maybe bring some empowerment to the conversation as well, because when you purchase a house, it's your first house, there's so little understanding of the different parts. And a lot of times when people buy a house, they're really connected to the excitement of how it looks inside and a little disconnected from what the day-to-day nuts and bolts of caring for their house are going to be. And I think it's a great idea to start with the first thing in the house, which is the foundation the house is constructed on. It's so often an underlooked and misunderstood part of the house, but so very important in so many ways, because all of the nuts and the bolts are in the basement or in the foundation.
Well, and it's not a place that a lot of homeowners spend much time.
So start first with the identification. I think that identifying it is important. And then knowing a little bit about the construction of these things. Having built houses. And I will say exclusively, all of the homes that we've built have been poured concrete, full basement foundations. It's ideally the material to use in the construction to use today here in the northeastern part of the country. But you do find those have components. The basements that are constructed out of concrete block have components. Identifying what those components are is important as well.
Yeah. All right. Should we go to the basement?
Let's go to the basement. Let's check for the critters first.
You go first.
You go first. This is a basement that, as we stand here, it's October 2023, this is less than 3 years old.
Okay.
So as far as representation of what your most modern construction materials and your most modern construction methodology is going to be, is indicative in this one.
Okay.
What we have here, instead of the beautiful dry stacked stone with a little bit of parge and all that, in the 223-year-old house, we have here in the new one poured concrete. So this basement was constructed simply by building a mold. It's almost like making chocolate, right?
Yeah, it's like you can see where the mold seams were.
Yep. They take these sheets of wood and metal, put them together, make a mold, and then fill it with climately appropriate, if that's a word, climate appropriate concrete. And then this becomes a solid monolithic structure. Everything that is put together, including things like garage floors and garages when they're attached to a poured concrete foundation, is connected in one monolithic way. They're not pieces that are put together, so that you get this incredible structural base to build your house on out of this beautiful monolithic concrete wall.
And can I ask you, do they pour the floor separately?
Yes. So
Okay.
The order that you pour a concrete foundation in, a poured concrete basement foundation or crawl space in, or even a slab, this is applicable there too. They start with footings, which are wider than the wall.
Right, so the footings go down even deeper
Yes.
than the floor here.
They're
And
under.
And they have to be below frost line,
Yes,
right? Because
absolutely.
otherwise the ground moves and it would heave. So if they go down below frost, they'll stay stable.
That's exactly right.
Okay.
So underneath this wall is a wider footing, which is literally, it just translates with the wall. It happens to be wider. So the first thing that a concrete contractor is going to do is pour those footings. The next thing the concrete contractor does is forms and pours the walls. The very last thing that gets done is the pouring of the floor. And that's optional. The floor is by choice. You could leave it dirt. Underneath the floor in a newer construction home, even in a home that could be as much as 30 years old, is going to be a layer of plastic, and that's there as a vapor retarder. And that's there also to keep everything smooth and make sure that nothing's jutting up when they pour the floor, because it can create a little bit of weakness in the floor and do something like create a crack or a heave. So underneath us right now is 4 inches of poured concrete, and underneath that is probably 6 to 8 mil plastic visqueen vapor retarder. So it stays in here very, very dry. Almost climate controlled, depending on where you live, to the extent that you don't need to do something here to manage the climate. You don't necessarily need to heat in a basement like this or air condition in a basement like this to keep it comfortable.
Yeah, I mean, it's a very comfortable, probably about 68 degrees right
perfect.
now. Yeah, so it's perfect.
Perfect all year.
Now, can I ask you, so there is a crack in the floor here. Is that
Yes.
something that is a flaw in the construction, or something that is to, anything to be concerned about?
Cracks in poured concrete slabs and poured concrete floors are generally not. They're almost always cosmetic.
Mm-hmm.
And what they're created by perhaps is maybe a little bit of temperature dysregulation when they're pouring the floor and when it's curing. Or sometimes it can come from settling, because anything, the stacked stone cellar or this poured foundation or a concrete slab on grade, even a crawl space, you're at the will and the mercy of what's going on underneath you.
It's still earth.
It's still earth.
It's living.
It's been dug. It's been moved around. It's been jostled around, and you get a little bit of settling. And those cracks are typically formed by settling.
Yeah.
Sometimes you'll see them in walls, and when they're minor like this, they're cosmetic.
And if they're vertical in a wall, in a concrete wall, if it's a vertical crack, it's just,
Stress.
it's stress. But it's not necessarily, if it's just, it happens and it doesn't get bigger or anything
Exactly.
like that, it's usually okay. It's the horizontal cracks, I know, that you
Not
have
so
to worry
great,
about,
yes.
because that's shearing in that,
Yes.
and that can mean a weak foundation.
It can mean a weak foundation. It can mean earth moving,
Mhm.
and it can mean pressure. The same way that we saw bulges
With the bulges, yeah.
in the stacked stone.
I mean, that's a big difference between the dry laid stone and this foundation, the poured concrete, is that the dry stone can continue to move,
Mm-hmm.
and it will shift over time, which is not necessarily a bad thing, but it just has movement in it. It's designed that way. This is designed to be stable. So, if it's done well, you definitely don't want to see those horizontal cracks. If it has some small vertical cracks, that's okay. But this is not completely impermeable. Like, there's still some concrete is still a porous material.
Exactly.
But it's got like a coating on the outside, right, to keep the water.
You've got, when you could excavate even an older foundation on the outside and do exactly what is commonly done with new construction. With new construction, on the exterior of these walls up to the grade level, which is the top of the dirt, right,
Mm-hmm.
the top of the ground, they usually use some kind of waterproofing material. Sometimes it's hot tar, sometimes it's foam, sometimes some sort of impermeable water resistant barrier. Oftentimes too, what people will do, depending on the climate, is attached to that water barrier foam insulation, so that you can further protect against the cold of the ground, the wet in the ground, and that helps to facilitate a nice dry, climate controlled environment,
Mm-hmm.
and also protect from water causing issues against the wall itself.
Because that's really just the principle. I mean, one of the first principles of building envelope is you want to keep the water out from the outside. Because once the water gets into the wall and migrates to the interior, because sometimes you see like that parging that you
Mhm.
saw, like where you're trying to stop it on the inside, or even sometimes an older poured concrete basement that may have cracks or water getting in somehow because it wasn't properly sealed from the outside. And you see like people put in whole systems to try to like keep the water out from the inside. I feel like once the water gets in, the most important thing is to make sure that it gets out.
Yes, do
Because you're not going to be able to push it back. that way.
Exactly.
So sometimes you'll see like those like the French drains, like the drains that go all the way around.
All along the perimeter.
Yeah, and then they'll go to a sump pump, And so if water is getting in from the outside, it's not the end of the world. You just want to make sure that it gets out.
Direct it out.
Yeah.
So preventing water from coming in, or the act of trying to move or relocate water, serves a couple of purposes. The first purpose is the obvious purpose, which is that water can be structurally damaging. The other thing that it does too is that moisture does create some issues with mold growth inside a basement.
Yeah.
It creates issues with climate control issues in a basement. Underneath, not in this particular house, because it is one, like as you said, codes are constantly changing and constantly moving. We are one code book away from modern code today. The house that we are currently constructing, being most modern code, I had to put foam insulation underneath the slab floor.
Yeah.
And that's designed to keep cool and moisture out from coming up from the floor.
Right.
Concrete is a permeable material. That's exactly right. And that's evidenced and indicated by the fact that you can have gases from underground, like radon gas, make their way through the porosity of the concrete and end up in your house. Radon gas is born of the ground.
Yeah.
And it enters from the underside of your house.
Another amenity of this basement.
That's a nice thing. So basements, you're subterranean. And when we drain water anywhere in any basement or anywhere in the world, it's always draining downhill.
Yeah.
It only ever goes
Water
downhill.
Goes down.
So this is a bit of an anomaly to physics, right? But it's a nice thing to have. So we're directly opposite of an outside entrance. This is a great thing to do if you want to pot plants or do anything. You need to wash your hands or painting, whatever. To put a sink like this in is a possibility because they have a pump system for the drain.
So the water goes down this drain into this trap and then to this pump.
Exactly.
And then the pump sends it, like the sump pump that we were looking at.
Exactly.
It sends it into the
sewer drain.
The sewer drain. Yep.
So, and because we're in the basement and we're so close to all the wonderful things, like where the water originates and where the hot water originates, this is a nice double bay hot and cold water utility sink.
It's good to know because, you know, we were talking about when you're doing slab on grade, you've got to plan like all the drains, all the supplies, all of that, because once you've poured that slab, you're done.
There.
Whereas a basement, you have a little bit more flexibility because you can always go up through the ceiling. But if you want to have this kind of thing, whether it's a laundry or it's a sink or even a basement bathroom, it's good to know that you don't necessarily have to drill into the concrete floor.
Exactly.
You can do something like this where water's still going down, but then it's forced
pumping
to go
back up.
Yeah, it's a really nice thing.
Yeah, and that's how you can enable yourself to have a bathroom in a basement, which is a super nice thing. Something you have access to from outside.
Oh yeah.
Everybody's outside, hanging out. Kids are playing outside, that kind of thing.
Yeah, it's truly beautiful.
Yes, this is very beautiful.
So it's a similar system to what we were looking at in the other house. It's bigger.
Exactly.
It's actually a smaller boiler.
Exactly.
I don't know if that's because the technology changed, that it was able to be a smaller unit.
This boiler is offset by a heat pump.
Oh,
and that's why it's smaller. So
it's a combination of gas and electricity?
Exactly.
Okay, got it.
So the heat in this house and the air conditioning to certain temperatures are provided by this heat pump.
Okay, because heat pumps are good as long as the temperature isn't like really, really cold.
Exactly.
Okay.
Exactly. Heat pumps can manufacture air conditioning, but sometimes need to be supplemented with an additional form of air conditioning with a compressor or a mini split. But this boiler is here to do two things: manufacture hot water. That's it. The heat pump does not make the hot water, and also supplement the heat pump's manufacture of heat to that radiant floor heating system in the event that the temperature drops below 15 degrees.
Okay.
And this is set so that if the temperature outside drops below 15 and the heat pump needs supplementation, this will begin supplementing heat to the radiant heat system. So it's smaller.
Mm-hmm.
Yours doing the whole house. And this piping, this is a house that has 3 zones of heat plus a zone of hot water. This house is primarily constructed on one floor. So these things have to travel in a way that impacts their
right. So
efficacy.
they have a longer distance.
Exactly.
So it's like they've got to maintain that temperature till they get to wherever somebody turned on the faucet.
Exactly. We have something here too that's a little different and a little interesting. This tank right here, which is almost always mistaken as a hot water heater.
That's
mistaken
what I would have
for
thought.
a hot water heater. The boiler makes the hot water here.
That heats the water.
That heats the water.
Runs it through all these pipes.
Yeah, here are some pipes that are used to help feed the radiant tubing with hot water. Then we have one that comes over here with hot water in it. It's stored in there and it's kept warm. That is a tank with a jacket around the outside of it.
Okay, so this is all insulated.
Yes. Yes.
Which hot water heaters often have insulation also, but its only goal is to store hot water so that you've got a good supply on demand.
Yes, and keep it warm.
Yeah.
That's what this is. It's a storage tank that has a jacket around the outside. The jacket is filled with hot water. And that's there to keep the water inside the tank from losing temperature and becoming colder.
Okay. So it's not actually heating. So that's heating the water. It's sending it over here
To store.
But it's also heating the water.
The jacket around the outside to keep it warm.
Yeah.
Yes.
Sounds very efficient.
Yes, this is a nice, efficient way of storing hot water without having to continuously heat it at the same time.
Yeah, exactly. Because that's what's always so frustrating when in this situation where, I mean, the boiler is the hot water heater. It's combined into one, so it's all off the boiler. You don't want it to constantly have to run.
Exactly, you're wasting fuel.
Yeah, you're wasting it if there's not a demand at that moment for hot water.
That's right.
So this is an efficient way to store it so you've got a good supply when you do need it.
Exactly.
So Desiree, tell us about this contraption.
This contraption is a reverse osmosis drinking water system. This is one of the benefits to having a basement and being able to run pipes and tubes and electricity up through a basement floor. This little machine makes super, super, super high quality clean water, and it sends that water to two locations up in the ceiling. The first location is the refrigerator, which has an ice machine and a chilled water dispenser, and the other source that it runs to is a little separate spigot at the kitchen sink, so you can draw pure drinking water for consumption and cooking. And it happens to be centrally located, and it lives here so that it's not taking up space in the kitchen sink base.
So here, do you have a UV light also?
No.
There's no UV light here,
No.
but does this perform the function of dealing with bacteria? Okay, so this is really more for what kinds of water impurities?
This house is adjacent to a vegetable farm, and one of the concerns was making sure that there's nothing leaching in from the soil next to this corn farm.
Right, so that's something that people should know about if they're living in a rural area where they're dependent on well water, because there have been generations of agriculture and different chemicals that have been used and things like that. So if you really want to ensure that your drinking water is as pure as it can be, this is a kind of system that you can consider. It is not for water storage. It is a pressure tank.
Exactly.
Okay.
That is exactly right. So in this case,
this
house
is a much bigger house than the house we were in before.
Yes.
So you wouldn't have a smaller storage tank. It's just that it's just a different style.
It's a different style tank. So this house has a modern well pump, not quite like the submersible pump that is in the house that we just came from. This is a constant pressure, variable speed pump. And what this pump does, still located in the well in the ground, but it's triggered to turn on in a different way. The way that this one turns on is by sensing a very, very small gradient change in pressure. The one that was in the house that we just came from, you needed to swing 20 pounds pressure before there was going to be enough of a change to cue the well pump to come on. This one does that in less than a pound. And it senses the slightest relief in pressure, and it turns the well pump on using a controlled amount of power so as to deliver on demand the specific amount of water you're asking for, not not the way the other one worked, which was not on demand necessarily. Instead, the other one had a bigger tank, and what you were doing when you relieved the pressure and caused the pump to come on was first you were attempting to fill to the high pressure point, hence the tank was larger.
Mm-hmm.
This one's smaller, but all the same features exist here. You still have this, albeit smaller, pressure tank. You still have a pressure gauge. You still have a pressure relief valve. You still have the sampling tap that you can use to drain the system down, or you can hook a hose up to it and use it.
Yep.
You still have a shut-off valve.
And yours is easy to read.
Yes.
On, off.
On, off. So yes, this is just a more modern version.
The house that we were in before was probably about 10 years ago. So is this new technology since then, or it's just different?
This is new technology since then to residential home construction. Variable speed pumps were something that they were sort of for industrial applications or commercial applications. They've become more readily available, easily affordable, and scaled down to make sense in a 2.5 bathroom house.
Right. So this would be the standard now in any renovation or new construction.
This would be the standard, I think, wish list. You can bring water into a home using a submersible pump the same way that most houses use, but this is a bit of a wish list because what it's going to provide you with is a much higher flow rate of water. It's like having municipal water in a well water house. They usually consume a little bit more electricity. They're not always indicated for every well because there has to be enough water refill rate in the well so that the pump doesn't outstrip the well's capacity to refill. So it's probably I'd really like to have this kind option.
Okay, but it depends on what kind of well you have, how much capacity it has, because I mean that's something to remember is unlike municipal water where there's just water constantly flowing, a well, depending on how deep it is, it's its own storage tank. There's water stored in the well and it refills at a certain rate. So if your well equipment outstrips the pace of your well, then you're out of whack.
You're gonna run out of water in times of high usage. Like imagine having guests. You have a couple or a family stay with you, and all of a sudden your water usage has doubled or tripled. If your well from Mother Nature can't refill itself at the same pace as that pump, you're gonna suck it dry. Same is true of the smaller ones, the regular submersible well pumps as well, which is a field of like a mechanical trade in and of itself, figuring out how much water capacity is there
and matching the equipment.
Exactly. So whatever well professional you are seeking advice from regarding replacing a well pump should be taking into consideration what kind of refill rate that well has and the storage that's in the well itself, which is 1.5 gallons per foot of depth.
Okay.
So if you have a 200-foot column of water in the ground, you're going to have 300 gallons of stored water in your well to use up before it even really starts to refill itself. It's really a pretty perfect system in a lot of ways.
Yeah.
This house, we've got a lot of steel here. Normally in a basement, when you're using wood as your primary means of construction, you'll end up seeing these columns everywhere because you need a little bit more column support when your structure is constructed entirely of wood. In this case, all the wood that was going to carry load was converted to steel beams, and an engineer designed this beam system and these couple of columns that are in this basement to bear all the load of the roof structure and the walls in this house. So this column's permanently installed. It will translate load or transfer load from these beams down to the footing, which is underneath. So you've got a footing that runs underneath here for this entirety to help carry the weight. So these are permanent, can't be adjusted, designed by an engineer, and this house should be able to structurally stand for centuries, debatably.
Right, because steel has both compressive strength, so it's like if you're pressing down on it, it's strong this way, but also in a horizontal, it's got that tensile strength too, whereas wood is going to deflect like that. It's always got a little give to it. Steel has virtually no give.
Yes.
So so the framing of this house, it's very, you don't have a lot of columns kind of getting in your way down here. The beams are, spaced pretty far apart. I assume that underneath this insulation, there are floor joists.
Yes.
So we've got another situation where we got radiant floor heat. So we're trying to reflect the heat up into the living space using insulation.
Yes. So this house was constructed, in modern basements do these beautiful things in modern houses and modern framing to open up as much of the space and make the space as usable as possible. Above this foam is not a typical joist. It's not a piece of dimensional lumber. It's a truss.
Okay.
And those trusses, they look a little bit like webs.
Like a bridge.
Like a bridge.
Yeah.
That's exactly right. It's like a bridge. And it has beautiful openings that you can do things with, like run pipe through, run radiant pipe through, run electric line through. And if you look carefully here, there isn't a lot on the walls here. Everything is in the ceiling, which makes this space, which is a typical 8-foot wall, something that you can really finish and you can utilize.
Oh yeah, you could finish this. I mean, you've already got like nice clean concrete walls, but you could put drywall down here. You could put like a different kind of floor. I mean, it's definitely usable space. So did you have fun down there?
I had fun down there. No snakes.
No, there weren't snakes.
It's
and only dead spiders.
Dead spiders. This was a great basement experience.